Value Stream Mapping Program, Section 1. Value Stream Mapping, an Introduction, Visualizing Flow and Eliminating Waste. A value stream is the complete set of steps needed to deliver a product or service, from customer request to delivery. It includes both value-added and non-value-added activities. The map shows how materials, services, and information flow through the process. By visualizing it, we can spot wastes and design a better, more efficient future process. Organizations use value stream mapping to see where time and effort are wasted in their processes. It helps reveal hidden delays, align different departments, and measure how much work actually adds value. VSM supports Lean and Six Sigma projects by showing where improvements can be made. Overall, it drives strategic gains in quality, cost, delivery, and morale QCDM. This slide compares a process map and a value stream map. A process map focuses on steps and decisions. It's more about what tasks are done. In contrast, a value stream map focuses on the entire flow and performance of the process. Process maps are qualitative, while VSMs use measurable data like cycle time CT, lead time LT, first pass yield FP, and work in progress VIP. Process maps look at one department, but VSMs show the full journey from supplier to customer. Finally, the outcome of a process map is a procedure, while a VSM helps create an improvement roadmap. Value means any activity that changes the product or information in a way the customer is willing to pay for. Waste, on the other hand, includes all actions that don't add value, summarized by the acronym TIMWOODS: transport, inventory, motion, waiting, overproduction, overprocessing, defects, and unused skills. For example, in manufacturing, painting 50 items at once causes overproduction. In services, re-entering customer data is an example of overprocessing. VSM helps us identify and remove such wastes to improve flow and efficiency. These are the key metrics used in value stream mapping. Cycle time CT, time taken to produce one unit. Changeover CEO, the setup or adjustment time between two products or batches. Lead time LT, total time from when the order is received to when it's delivered. Takt time TT, the pace at which products must be made to meet customer demand. First pass yield FP, the percentage of products made right the first time without rework. Uptime, the percentage of time machines or systems are available and running. These metrics help visualize efficiency and identify improvement areas in the process. This example explains how Takt time helps identify bottlenecks. If a shift has 27,000 seconds available and customer demand is 900 units, the Takt time is 30 seconds per unit. But if the assembly process takes 38 seconds per unit, it means the team can't meet the customer demand. That's a bottleneck. So, the Takt time helps us see where the process is slower than the required pace, allowing us to focus improvement efforts there. This example shows how queue time affects service performance. The help desk has 28,800 seconds available per day and receives 120 tickets. That means the Takt time is around for minutes per ticket. However, if each ticket takes 3 minutes to handle and customers still wait 30 minutes in the queue, the issue isn't the agent's skill, it's a flow problem. This tells us that improving the process flow or balancing workload is more important than training in this case. The lead time ladder helps us measure how efficient our process flow is. We add up all the value-added VA times and non-value-added NVA times like queues or waiting. Then we calculate %VA equals VA divided by LT to find how much of the total time actually adds value. For example, if VA is 133 seconds and total lead time is 5.2 days, only 0.03% of the time is truly value-adding. This shows a big opportunity to reduce waste and improve flow efficiency. When starting a value stream mapping project, we must first select the right product or service family. We use a PQPR matrix, which stands for Product, Quantity, Process, and Resources, to identify families with at least 80% common routing. We should avoid mixing different families because that can make the analysis confusing. Lastly, focus on the DORTUD or scope, meaning the entire process flow from the start to the end of value delivery. In a value stream map, we show both information flow and material or service flow. The top lane represents information like orders, schedules, or emails, how instructions move. The bottom lane represents materials or services, such as parts or files, how the actual work moves. Interestingly, most delays and inefficiencies happen in the information flow, not the material flow. So improving communication and coordination often gives big results. When collecting data for value stream mapping, we always go to the Gemba, the actual place where work happens. Observe around 10 consecutive units for each process step to get reliable data. Record key metrics such as cycle time CT, process time PT, changeover CO, work in progress VIP, first pass yield FPY, and queue time. Use interviews to confirm issues like rework or blockers, and for service processes, rely on timestamp logs to track real-time delays. This ensures that our VSM data reflects reality, not assumptions. This mini case shows a problem between the paint and assembly stages. Painting takes a long changeover time of 60 minutes and produces in batches of 50, creating a work-in-progress WIP of about 1,200 pieces, which equals 2.5 days of inventory. The assembly process runs at a cycle time of 35 to 40 seconds, but during paint changeovers, it has to stop. This is called being starved. So here we see wastes like overproduction, waiting, and excess inventory, all caused by uneven flow between the two processes. This mini case shows a value stream mapping example in loan processing. The total lead time is 2.1 days, and the KYC first pass yield is 89%, meaning there's rework in 11% of cases. Underwriting happens only once per day, which causes waiting and rework due to batch processing. Possible improvements include using checklists to reduce errors, auto-validation to avoid manual mistakes, VIP limits to control workload, and triage to prioritize urgent or complex cases. These steps help improve flow and reduce turnaround time. Here are some common mistakes people make while creating a value stream map. First, they map the ideal process instead of what actually happens. Always start with the as-is process. Second, many maps don't include real data in the boxes, which makes them less useful. Third, mixing product or service families creates confusion and incorrect insights. Fourth, people often ignore the information flow, even though most delays happen there. And finally, some teams treat VSM as a one-time activity, while it should be updated regularly to track improvements. Today, we'll identify waste, calculate talked time, set clear scope boundaries, prepare for current state mapping, and finish with an activity and recap.